In this demo, I will be showing how sensitive data can be stored in the Google Cloud while still being secured thanks to the Crypteron security framework. To begin, I will use Compute Engine to create a new VM instance for running my application. Since this will be running the backend of the app, I'll name this instance backend. It'll be running in the US Central Zone with a standard machine type, and for the boot image, I will choose an already prepared Debian image with some software that I need for my application installed. On the firewall, I will be allowing HTTP traffic in, as this is a web application. And now when I click Create, a new instance is being created in the cloud with the Debian image Google provides. On top of that, I have already added Git for version controlling my source code, as well as the JDK version 8, as this is a Java application. This is needed for compiling and running the application. And I have also used Apache Maven in my project for build purposes. Now that this instance is created for my compute, I would like to be able to scale the application in the future, and so I wish to store my data on a separate instance. Google provides a cloud SQL, which is based off of MySQL, for storing data in. Before I begin creating that, I'm going to copy the IP of my instance so that I can set up connections to it properly. So next, I will be choosing Cloud SQL here and creating an instance. I'll name it data, as this is where my data is being stored. Keep it in the same region as my app server and choose a standard tier. So this will provision a new SQL instance, essentially an entire database server on my behalf, that will allow me to connect using standard MySQL drivers and application software that's already been developed. In my application, I will be using Hibernate to connect to the database. And I will be also using the Java Persistence API, standard JPA syntax, for doing that communication. So when this SQL instance is finished provisioning, which is now, I'm going to quickly set this up by adding a database for storing my data in. I'm going to name that Showcase here. And next, I'm going to set up the access control for my SQL so that I can connect to it from my application. First, I'm going to need to add as an authorized network the IP of the instance that I already spun up for my compute earlier. And in addition to that, I'm going to be adding my own IP address so that I can connect to and inspect the data on it. So when I click Save, you'll notice there's a warning here because I have specified version 4 IPs. However, currently, if I look at IP addresses, I do not have an IPv4 address assigned. So I'm going to request one. And I'm going to copy this address for using when I configure the application to connect to it. So the only other step that's needed here on the SQL side is to create a user account. I'm going to name it the same as my database, Showcase, and I'll use a simple password. So now that that's created, I'm going to use the MySQL Workbench software that's already provided for connecting with any standard MySQL instance. And I'm going to actually use that to connect to my cloud instance here. So I'll use the host name and user that I've already provided, my simple password, and now when it connects, you'll see I have a schema called Showcase, which is essentially empty. It has no tables, but it is fully configured and ready for my application to use as its data store now. So next, I'm going to go back to my compute instance here, and I'm going to SSH into the backend. Now, the first thing I'm going to need to configure is the connection to the database that I've already created here. And that information is supplied to my application using environment variables. So I'm going to begin by configuring an environment variable so that it knows which host to connect to. In addition, I'm going to provide which database, as well as which user to use, and finally, which password with my simple password there. So next, now that I have a way to provide data to my application, I want that data to be secured, because in this case, the data I'm going to be storing is actually going to be patient data, which is going to be subject to HIPAA regulations. So the variable that I want to use to provide Crypteron with that configuration is known as the app secret. Now, in order to get the value for this, I'm going to log into my dashboard for Crypteron at my.crypteron.com so that I can create an application for providing this data management. So let me log in first. You'll see that I currently have no applications, but I can very easily create a new one. So I'm going to name it for the security showcase. I'm going to pick the developer plan in this case, which is perfectly fine for initial development, testing, hacking, that sort of work. And I have other options as my workload scales upwards. So now that I have created my application, you'll see we've populated some data automatically on your behalf. So we have the concept of security partitions for separation of the data. We have a default one already provided. This provides initial key version which can be rolled over. We have an access control list with a single role that has permission to decrypt and encrypt, but multiple roles could be added in the future for finer grained control. Multiple partitions could be defined if you had a multi-tenant situation, or other ways of you wanting to partition your data. We have a pause feature in the event of a data breach or other event that you want to temporarily not allow your application to access. And most importantly for us right now is we have an app secret which is provided on the application to secure communications with our API. So I'm going to copy that app secret, paste it into this environment variable that I've already started here, and set the value. Now that I have all my environment variables set, I can begin checking out the source for my application. So I'm going to use Git, and I'm going to actually pull down from a GitHub repository. This is public. And I'm going to change into the repo that we just checked out here. And so in this case, you'll see we have a standard Maven project. For those who aren't familiar, the build is defined in the pom.xml. In this case, the way we are going to start our application is actually using a Jetty Server, which is a lightweight container used by Google on several projects and also provided in their app engine. I'm going to be using Maven to instantiate that on my behalf after a build is complete. Now, because this process is running as a regular user and I don't want to have to elevate privileges, I don't want to have to open up port 80 to my regular user account. So one last step I need to do here to make the whole thing connect together is I need to add a firewall rule so that when clients try to connect to my port 80, they'll be redirected to 8080, which is where the server is actually going to be running. So with all of that preparation work done, I can now use Maven to perform a Jetty run. So what you'll see happening here is, first of all, Maven is going to download all the dependencies it needs to build the application. This is going to include all of the web for the UI, as well as the backend, including the Crypteron security framework itself, as it's published publicly in Maven. You'll see it's doing the compilation now. It's a fairly quick build process. The next step is now it's downloading all the dependencies needed to start Jetty, which it is now doing, and Jetty is now running. So with that complete, I will now open the IP for my backend instance. And you'll see the application starts up. In the log here, notice that we're using Hibernate, and its schema update tool has determined that the tables that my application wanted to use were not already defined, and so it created them on my behalf. So those tables correspond to two tabs we have here for looking at an insecure table of patients and a secure table of patients. If we look at the MySQL workbench here and do a refresh, you'll notice that it created both of those tables on our behalf. And they are actually completely identical from the database schema perspective, with the one difference of the name of the table itself. So let's take a look at what the actual application functionality is able to do here. So we can do fairly basic CRUD operations. Let's add a patient at this point. So now that we've populated some data into here, we can go back to Workbench, and let's take a little look here at what the data looks like that we've just stored. So you'll notice that we have the first name, last name, which are stored in the clear, but more troubling than that, we have here the social security number of the patient is actually being stored in plain text. So this could be potentially SQL injected out. If someone had another vector for attacking this machine, they could potentially compromise that data. This is not going to meet any sort of HIPAA compliance. So let's change over now to the secure view of Java patients rather. And let's add a record in here. So say myself with some data. And now if I go to the patient table, which is where that view was using, you'll notice that the data is stored quite differently in this case. For all three columns, we have the data is no longer in plain text, it is encrypted, it is undecipherable to anyone outside of our application. So to take a look at how we accomplish this in the code, let's look at the entities that we've defined for each of the two tables that we were looking at before. We have an entity for the insecure patient, which has the same fields that you were seeing on the screen for the name, first and last, as well as the social security number. And now we have the patient entity, which has all of the same fields defined, but you'll notice that three of them have this annotation that Crypteron's provided for marking which properties need to be secured, and in this case that security is provided with encryption. So right now you'll notice that the only changes we've had to make to the source is notating which data we want to secure. And what's even more interesting is if you look at the controller logic for how each of the endpoints operates. So you'll notice we have one that operates at the path for insecure patients, and then a second one that operates simply at patients. These two are extremely similar. They simply operate in insecure patient entity objects versus the regular patient. And each of them uses standard JPA syntax. They use entity managers that do queries and return result lists. They do finds. They do merges when data needs to change. They do removes for deletes. But there was no source changes required here, no custom code, no extra application logic to handle that encryption. All of that was provided automatically and transparently. And that's how easy Crypteron can make securing your data in the public cloud.